And we are going to be going over this problem today. So here we have, this is about geyser eruptions, and these are the lengths of the geyser eruptions, and this is the time between each eruption. And we have this sample of 8 geyser eruptions. Now the question asks, does the residual plot confirm that the relation between time between eruptions and length of eruptions is linear? So here we don't have to calculate anything. They've given us the residual plot of the data. So we just open this up, and the residual is actually the leftover distance between the predicted value and the actual value. And what we see here is we don't really have a pattern that is very clear. And so if there is a pattern, then there's something else that's explaining the relationship, and besides something that's a linear relationship. So here we don't have a pattern, a clear pattern. So let's take a look at our answer. So there is, yes, the plot of the residual shows a discernible pattern. No, that wouldn't work. So the plot of the residual shows no discernible pattern, implying that the explanatory and response variables are not linearly related. That's not true. They would be linear. No, the plot of the residuals shows that the spread of the residuals is increasing or decreasing, violating the requirement of a linear model. That's not the case. Yes, the plot of the residuals shows no discernible pattern, so a linear model is appropriate. That looks on track. So let's see if that's correct. Good. So, and basically that's just telling us that if there's a pattern on the residuals, there could be something else that's explaining the variation besides the linear pattern. So here, the coefficient of determination, we have, it's found to be pretty high at 87.1%, and we have to choose the best interpretation of that. So it is, the coefficient of determination basically measures the percentage of total variation in the response variable that is explained by the least squares regression line. So here, the least squares regression equation does not explain 87.1%. No, that it would explain. So the least squares regression lines equation explains 87.1% of the variation in length of eruption. That looks on track to me because it's explaining the response variable, which is the length of the eruption. So let's check that. That looks on track. And so hopefully that helps, and please email me if you have any questions, and thank you so much for watching. Have a great day.